Suppose your teacher asked you to be part of a group of students in charge of organizing a small program that would be held after a parent-teacher meeting. What would you do? Any such activity requires a lot of organization. In this case, perhaps the first thing you do is have a group meeting. There you would decide on the actual events that would take place during the function, perhaps a song, a dance, a recitation, maybe a small play. Then you would have to decide on the order in which these events would take place, the people who would perform, and what they would actually do. Once these are fixed, you would have the first draft of the program design in place, and you would probably ask your teacher to approve it. After that, depending on your teacher's suggestions or various other factors, you may change the design in small ways to make it better. This is called fine-tuning. The actual work of rehearsals, practice, writing scripts and speeches, etc. can begin only after all these initial steps are done. The process of designing a database is similar. You have to decide on the things you need, organize them in the right way, and follow a set of steps to design and then fine-tune it. In this lesson, we will take a closer look at these steps. Microsoft Access is a relational database management system, RDMS, used to manage databases. Designing a database is an important process that requires time and effort. A good design leads to the creation of an effective, accurate, and efficient database that stores data in exactly the way you want it and enables you to access it easily. Database design involves 7 crucial steps. Step 1. Identify the objective of your database. Step 2. Identify the tables you require. Step 3. Identify the fields you require. Step 4. Identify the primary key or fields for unique values. Step 5. Define the relationships between tables. Step 6. Evaluate your design. Step 7. Insert data and create other database objects. Now let us look at each step in detail. The first step in database design is to identify the objective of your database or the purpose for which the database will be used. For example, a database that stores stock quotes to help analyze market trends will be different from one that stores images to be used in advertising. You also need to determine the type of information you need to store, as these would form your tables, and the actual information you would store, as these would form the fields within your tables. We will look at tables and fields in greater detail over the next 2 steps. The second step is to identify the tables you need for your database. For example, to design a library database, you would require tables on book details, book issue details, member details, etc. Determining Which tables you should include in your design is one of the most challenging steps of the database design process. You will need to think carefully about the output you want your database to produce. The reports, articles, forms, or pictures that you want to see. Then calculate backwards to find what you need to use to get that output. This is a difficult task. It is a good idea to first create an outline and sketch your ideas on paper. Analyze this and check for flaws. Make it as perfect as possible before you get down to the actual design. When designing the tables, keep 2 points in mind. 1. The same information should not be stored in more than one place across tables. This means there should be no duplication of data at all within tables. This will prove advantageous when you start using the database, as you will only have to update information in one place. It will also reduce the risk of duplicate entries appearing with different information in case you forget to make updates everywhere. 2. Each table should contain information about one thing only. To use the library example again, you would have one table on book details, another on membership details, etc. You would not have book and membership details in the same table. This will prove advantageous when you need to add, delete, or change a table. As information is maintained separately, modifying one table will not affect another. Once you have identified your tables, the next step is to identify the fields within them. The fields within a table contain facts directly related to what the table is about. For example, a book details table can have fields such as book ID, book name, book author, publisher, edition number, etc. Here are 4 guidelines to keep in mind when designing fields for your tables. 1. There should be no duplicate field values across tables. For example, no 2 customers can have the same customer ID. 2. Each field should relate to what the table is about. For example, in a customer information table, all the fields should only contain information about the customer. 3. No fields should be created for derived or calculated data. 4. There should be separate fields for the smallest logical bits of information. For example, don't create a single field for address. Instead, create separate fields for street, city, state, and zip code. Once all the tables and the fields within them are set, you need to identify a field or set of fields that will contain unique identification data. This unique identifier is called a primary key. This key enables Microsoft Access to connect information stored in different tables. This field cannot be left blank and cannot have duplicate values in the table. For example, in a book details table, book ID can be the primary key. In this case, each book would be assigned a unique ID. Now that your tables are in place, you need to relate them to each other in a logical way. To do this, You need to define the relationships between tables. The relationships tell Microsoft Access how to bring related information together in order to create the report or find the answer that you are looking for. Tables are related by using the common fields within them. You have now completed your database design. But before you start incorporating actual data, analyze the design and try to spot flaws. Check to see if there are any gaps in logic, any field that would fit better in a different table, any relationship that has not been defined, etc. Refine the design, making changes as required. Remember, it is easier to change the database design before you fill the tables with information. After completing the design analysis, if you are satisfied with what you have, then go ahead and add all the actual data to the tables. Your database is now ready for use. You can now create objects such as queries, forms, reports, and data access pages. Let us summarize what we have learned in this animation.